All right. Hello and welcome back to Science. Um, Today we will be talking about ice, wind, and wasting, several more forms of erosion, since erosion has been kind of the topic we have been talking about here in the past couple of days and weeks. Um, so the title here is simply Ice, Wind, and wasting away but still precious and desired. So what I mean there is, I'm playing a little bit off of the term they're wasting away. Like you might, hear of someone who's not being very uh, proactive at making something good of their life. They're just wasting away. Um, anyway, so I'm playing off of that a little bit with this erosion thing. The soil and stuff is wasting away. Um, but we still want it. It's still desired. Um, anyway, it's awful. It's not a good subtitle, I know, but I tried my best. All right. So first of all, talking about erosion by ice. So what we mean is glaciers, essentially. And glaciers are simply a thick sheet of ice that can flow because of the immense pressures from its own weight. So snow piles on top of snow, and you get this really, really, really thick layer um, of ice going on. And when ice is put under immense amounts of pressure, it can actually it actually kind of becomes a little bit of a liquid almost, and it can kind of flow a little bit like a river maybe, but it's not. It's obviously it's not a liquid, but it can kind of flow. I don't know how more to explain it, but it does. It works. Um, Now there's several different kinds of glaciers. First of all is a continental glacier, and this is defined as a vast sheets of glacial ice that cover immense areas of relatively flat land. And there's kind of two continental glaciers that we have. The first one is in Antarctica, covers most of pretty much all of the continent there. And then the second one is also in Greenland, and covering most of that. And yeah, so this is basically just a glacier that spreads out over the entire land. Um, Now we have these things we call ice caps. They're pretty much like continental glaciers, except they aren't quite as big. Pretty much is if you're breaking it down. So the smaller ice sheets that are not as large as continental glaciers, but they share very similar characteristics. When you look at them, they're just not quite large enough to call them continental glaciers. And then we have valley glaciers. These are also called alpine glaciers. But valley glaciers are smaller highland glaciers, and they're more numerous than other kinds of glaciers. And they slowly flow down mountainous regions like rivers of ice. These are um, we're probably more familiar with these kinds of glaciers. Usually, we find these in mountains, so usually not in. Uh, that's one of the differences between the continental glacier and the valley glaciers. The continental glacier is usually very gentle, sloping, almost flat, but the valley glacier is usually found somewhere on the side of a hill, usually a mountain. All right, so let's talk a little bit about how they move, or what that does, and some of the effects that comes about. So a glacier moves fastest towards the middle and towards the surface. So if you think of a glacier fitting into a riverbed, kind of, um, it would flow fastest in the middle here, and which makes sense because down towards the sides is where it will be. It is where it will be resisted by the dirt that is pushing out of the way. Um, it will be resisted there, and then in the kind of towards the surface in the middle is where it would have least resistance and it could flow the fastest. So it kind of makes sense. Now, this word is pronounced crevasses, I think. And just note there that it's different from a crevice, which is a crevice is just any crack or fissure kind of, whereas crevasses, yeah, something like that, is specific to a glacier. There's a deep crack or fissure in a glacier that forms in the surface of a glacier where there is less pressure, making the ice more brittle. So towards the surface, kind of, because there's not as much pressure there, it doesn't seem to be as 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 it's not as bendy, you might say, and so it breaks a little quicker. And then, all right, so then now we're starting to talk about what these glaciers can form. First of all, we have a cirque. A cirque is a huge bowl-shaped depression scooped out by the movement of a glacier. So a glacier moves here, and everything in its path, it just scoops out of the way, kind of leaves behind a bit of a depression. That is a cirque. And a rate, actually, is a sharp ridge that divides two cirques. So let's say you have a glacier going down a mountain here, glacier down a mountain here, then in the middle here you have kind of a sharp ridge. That would be an arete. And when you have multiple cirques or multiple glaciers going down a mountain, sometimes they'll form kind of a peak that's very pointy, and we call that a horn. It's a sharp, steeple-shaped point formed when three or more cirques cut into a mountain peak. The Matterhorn in the Swiss Alps is a classic example of a mountain that has been shaped by glaciers and has a horn. All right, then another thing that can form is a fjord, and this is a valley carved out along the coast that ends up filling with seawater. Fairly self-explanatory, kind of like just carving out a cirque, except this happens to be below sea level and it fills with water. And then striae is a word that we use to refer to the deep grooves and scratches placed in the bedrock underneath a glacier by large hard rocks pushed along by the glacier. So sometimes you have rocks that get frozen in this glacier mixture, and as they're pushed along, they actually also carve out more rock and stuff, and so the striae is simply effects of that happening. Now, till is a word that we use to refer to the huge quantities of broken rock that a glacier carried along until it melted, which is another word for that, is to say that it retreated during warmer weather. So essentially everything that the glacier carries along that is dirt is called till. And moraine is the accumulation of till left by a retreating glacier. So when a glacier stops and actually melts away, we call that, what it leaves behind, we call that moraine. And there's several different kinds. You can learn more about these in the section entitled A Closer Look on page 111 in your text. But there's terminal moraines, which is where the glacier ends, lateral moraines, kind of moraines to the side. Ground moraines would be gently sloping moraines, and medial moraines would be moraines kind of in the middle of two glaciers. Alright, so then we have drumlins, which are when an advancing glacier overruns its old terminal moraine, making the moraines smooth and forming low hills. So terminal moraines where the glacier ends and deposits its till, and then it overruns it, and you have these drumlins forming. Alright, very quickly, outwash is deposits of sand, gravel, and other sediments that are washed out from underneath the glacier by meltwater. So as it melts, it washes out some of these things. And then kettles are large bits of glacial ice trapped in till or outwash. And I think we'll stop there for now and pick that up in the next video.